Can y'all hear me? All right, awesome. That was a pretty easy tech handoff. Thanks for coming tonight. It's fantastic to be here. My name is Kyle Simpson. I'm much better known as Getify on those interwebs, Twitter, GitHub, and all the other places that matter. So if you find a place that doesn't have a Getify, it maybe isn't that, I'm kidding. But all those places you can find Getify, you can also find listed on my site. And you can also email me, Getify at Makersquare. That's pretty predictable, and I'll talk about Makersquare in just a second. So Makersquare is a developer engineering training school. We have 3 campuses, Austin, San Francisco, and right here in Los Angeles, Santa Monica area. And we are the cream of the crop as far as it comes to developer training schools. We have best-in-class curriculum. We take you from being a junior level developer to fully intermediate level engineer, and we get you a great job out of that, and that's our mission, that's our goal. I joined about 3.5 months ago now as head of curriculum to lead the charge to make sure that we take our already fantastic curriculum and push it even further and widen the net of where we teach and how we teach. And I am way up to my eyeballs in all of that, and it's lots of fun. But Makersquare is fantastic. If any of you have any thoughts or questions about that, you've wondered what training schools are about, or maybe you're sitting next to somebody or you have somebody at home that's kind of been wanting to get into this whole development thing and wasn't really quite sure how to do it, we at Makersquare would love to talk to you, and I've got a number of my coworkers from the Los Angeles campus. They're here tonight, so come and find us. We'd love to talk to you about Makersquare. In addition to that, we would also like to offer as a special offer for those of you in attendance tonight, and you can email us if you want to take advantage of this. We have a course called Maker Prep, which is basically a preparation course that gets you all those fundamental skills that you need before you can even get into a school like a Makersquare. So we have a pretty high bar. We like to think of ourselves more like the MIT of these developer schools. And it takes a lot to get in, but we have courses to help you get there. And one of those tools is called Maker Prep. And Maker Prep is a fantastic school. It's basically a 1 month, is that right? 1 month in the evenings sort of course. So you don't have to quit your job necessarily, but you're going to want to dedicate a lot of time and attention to that. And we're going to be offering as a special offer tonight for those of you in attendance, $100 off the normal cost of Maker Prep if you decide from what we talk about tonight that you'd like to join. So reach out to one of us if you're interested in Makersquare, want to talk to us or ask us questions. We'd love to talk to you about that. In addition to the work that I do with Makersquare, I do a lot with open source development, conference speaking, and book writing. So I have written a series of books on JavaScript called Know Nodejs. The entire 6-book, 1,100-page series is available for free online at GitHub. So if you go to JS.LA, it redirects to the GitHub repo. You can read the whole thing. They've also been edited and published through O'Reilly. So if you like what you see there, I would of course appreciate it if you buy those copies of those books. In particular, I want to highlight one of the books. The first book in the series is called Up and Going. It's written from, I don't know what happened. It is written from the perspective of somebody that has never done a single line of programming before. So it literally gets you up and going with the notion of what programming is and how to look at it from the perspective of JavaScript. So if you're looking for those sorts of intro resources, I get asked all the time, hey, do you know about intro resources? There's a bunch of fantastic stuff out there. A website that you may not have heard of before, JS for Cats, JavaScriptForCats.com. You should totally go and check that out. My book is also available for free, even in the ebook, the edited ebook form from O'Reilly and Amazon. You can get the actual ebook for free on that. So I don't want there to be any excuses for why someone wouldn't be able to learn and dig in to understanding JavaScript better. In fact, that's what my entire career is about, is helping people move from the, for lack of a better term, move from the good parts perspective of JavaScript, which is it's poorly designed and there's this tiny subset that's good, which I reject that notion entirely. I think it's a fantastic language. Hopefully many of you are here because you at least believe to some extent the same. But I wanted to move us beyond that whole good parts thing. That's what got us all here. But I want to move beyond that and go into the deeper understanding, learning all the parts of the language. That's what the book series is about. That's what the trainings that we do at Makersquare are about. So in addition to our courses, we also do corporate training. We can come and train in your company and help you and your team learn better. That's what it's all about, is understanding JavaScript better. So if you have any questions about that, I'd love for you to jump in. Before I do my talk tonight, I want to make a quick mention of something. And anytime I'm given an opportunity, a stage to talk to people, I find this to be very important. So please just indulge me for just a moment. I want to talk to you just for a quick, brief moment about what I call privilege awareness. I look out in the crowd and I see a pretty good mixture of folks, but I see an awful lot of dudes that look like me. to be completely honest, and I don't find that acceptable, that no matter where I go in the world and no matter what types of events I go at, we don't see enough inclusivity in the sorts of things we do. And this is not a knock on any individual person or any event or anything like that, but it's just to simply say there are structural reasons why our industry is not as inclusive as it should be. You notice I'm talking about inclusivity rather than diversity. Diversity is something that happens when you become inclusive. So we should be focused on inclusivity of everyone. And there are things that I have had in my life that have been privileges that have allowed me to get to where I am. And other people getting to the same spot have had to work a lot harder. And it's not fair. I have a daughter and a son, and I don't want them to come up in an industry where my daughter has to work harder than my son, where she's going to be second guessed. So the fact that I'm white and I'm male and I'm heterosexual and I'm an American and I'm employed and I'm educated, those are my privileges. So I'm simply talking about myself to say, we need to be aware of our own privileges so that we can be more empathetic of other people that have a more difficult path to get to the same spot. So I don't have a solution to the problems, but I know it starts with talking about it more. And I would like for each of you to take a challenge away from this, to ask yourselves, what is my privilege? What is my story and what is my privilege? And talk about it more. So I'm given an opportunity to say it, and I think we need to declare our privilege. So that out of the way, thank you. You'd be surprised, I actually kind of get a mixed reaction. Sometimes I get a warm reception, sometimes not so much to that, but I think it's important nonetheless. All right, so that out of the way, I'm going to talk tonight about concurrency in JavaScript, and that's closely related to this notion of async programming, so we're going to talk about that. The stuff that I'm going to talk about tonight, kind of the highlights and some of the advanced stuff from a 2-day training course that I give on asynchronous programming, a deep dive. So I'm trying to present that to you, and I've been given like 25 minutes to present to you what I normally do in 2 days. So I'll probably be able to trim this down to about 3.5 hours or so. I'm sure you all are excited about that. No, I'm kidding, of course. It'll only be 2 hours. But let's talk about concurrency in JavaScript. To quickly make you understand what concurrency is, I need to actually take a step back and talk about those terms async and parallel, because they're often confused as being the same thing, and they're really only the same thing if you really squint at it from a long distance away. There's some important differences between async and parallel. So async is kind of like when imagine at a theme park and you're waiting for a roller coaster ride and there's this long line and you all show up at you get to the front of the line and there's 30 seats on the car, but they're only letting one person onto the roller coaster at a time. So at any given moment, there's only one thing happening. Parallelism is when 30 people get onto that ride and all 30 of them experience the exact same thing at the exact same time. So where does JavaScript fit? We know JavaScript is async, but JavaScript is not parallel. Our JavaScript code runs in a fundamentally single-threaded event loop environment, which means at any given instant, only one of our functions, only one of our lines of JavaScript can be running. That may seem like a tremendous limitation, but it's actually a huge freedom. It's a freedom from having to manage all the complexities that parallel programming have. And if you've worked in a threaded environment before, you know all the complexities of mutexes and semaphores and all of this other crap that I don't even want to say. That's the life that you live when you work in one of those languages. So it's tremendous power, but also tremendous overhead in terms of programming. Very hard to get threaded programming correctly. In fact, I'd probably assert that virtually all threaded programs right now that have been written have bugs in them because threaded programming is so hard. So we don't have to deal with those particular problems in JavaScript, but we actually have a different set of problems. Concurrency doesn't mean at any given moment something is happening, like at any given instant two things are happening at the same time. But if you really look at what concurrency is about, it's about two higher level sets of tasks occurring within the same time frame. So rather than looking at an instant of time and saying there's two different cores running two different actions, what we would say is there's two higher level actions that are happening in the same period of time. So we might visualize those two higher level things as the blue and orange that I'm showing here on the screen, and I've broken them down into numbers to illustrate the idea that a higher level task is composed of, and I'm making up terms here, microtasks. So we have this macro level task and a micro level task. The numbers represent those micro-level tasks. So if the yellow-orangish color represents making an AJAX call and receiving a response back, and the blue represents scrolling the page and repainting and updating the location on the page. Those can be comprised of individual steps that may occur. So, if I were to pick the most naive scheduling of this program, and for our sake, for our intents and purposes, let's say that each one of these micro-level tasks takes 1 second to complete, then the entire system is going to take 7 seconds to complete. And the most naive way to schedule that is to simply do all of the orange and then all of the blue, or all of the blue and then all of the orange. And if you thought about it in terms of not being able to break down into microtasks, that basically would be your only option. And what you'd see is, wow, this system feels really slow because I click on the button to fire the Ajax, but the button doesn't repaint until 4 seconds later because I can't repaint the screen because something's blocking it. So instead, what we do is break down our programming tasks into as small pieces as possible, as little blocking as possible. These tiny little pieces can be ordered, they can be scheduled in a different way, for example, like this. And that animation took me about 2.5 hours to get just right in Keynote. I'm sad I didn't get rounds of applause out of that, but nonetheless, thank you. Such a cheap speaker ploy to get laughter and clapping. I'm bad at that. We scheduled this differently, and the system is still going to take 7 seconds to complete, but now the perception of the performance of the system is drastically different, because from a high-level perspective, they appear to be happening at the same time. This is a concurrent system. This is not a parallel system, it's a concurrent system. So our task as programmers is to understand concurrency. It's the cards we've been dealt in the language that we've chosen to write in. We need to understand and manage concurrency. And by the way, the complexity that we have, we don't have to deal with threads, but the complexity that we have is to figure out how to coordinate our concurrency. Because you might make several requests at the same time, and it's okay for them to happen in parallel. That's how we always say it. You ought to change to saying they're happening concurrently, but we always say, in common parlance, we always say they're happening in parallel. These two different Ajax requests and this one database request, they're all happening in parallel. Well, that's all fine and good. That's easy to do. The hard part is to make sure that the responses to those things are sequenced correctly. Because you may need to sequence, those three have to finish before the fourth thing can start, because it needs information from the first few. So it's the coordination of concurrency that makes our job difficult. And we have a number of different ways to coordinate concurrency. Built into the language is the humble callback. And in my trainings, I would go through all of the history of how the callback works, and we dissect callbacks and look at their practices and patterns. But we build from callbacks into a notion of promises. How many of you have heard of promises now? Okay, great, fantastic. So a quick primer on a promise. Here's a quick little idea of what a promise might be. And this is just kind of like a review of some ideas from promises and generators. So this talk is not really about them, but I want to make sure you understand them before we go to the other stuff. So a promise is like when I walk up to a counter at my favorite fast food restaurant and I ask for a cheeseburger. And the lady says, it'll be $1.39. So I hand her some money and I've started a transaction. What I'm expecting in response is a cheeseburger. But that's not often what she hands me. What does she give me instead? A receipt with an order number on it. It's a promise for a future cheeseburger. So now I can take this receipt and start to think about and reason about my future cheeseburger. I don't have the cheeseburger yet, but darn if I can't think about it. My mouth starts to water to think about this cheeseburger, so I step back and I'm waiting for those magic words, order 317. And a big smile on my face, I step back up to the counter, I exchange my receipt for my cheeseburger. That's what a promise is. It is a representation of a future value. It is a container that we wrap around a value where it makes it so it doesn't matter if the value is here or not. We continue to reason about the value the same way regardless of whether it's here or not. That's a real crash course metaphorical idea for what promises are. They are a container around a value that eliminates time as a complexity. Okay? That's one of the things that makes them so powerful. It's not about the API. There's a bunch of people out there right now that are like the counterculture, like, ooh, boo on promises, because all they focused on was whether the promise API was any good. And it's okay. It's better than what we had before. But promises aren't exciting because of their API. Promises are exciting because of their concept. It's a truly powerful concept to have a time-independent wrapper around a value. And whether they botch the API or not is actually a secondary concern. The important thing is, how do we use that tool? So promises are a way to represent something that may happen right now, may happen in the future, but I can compose these things together as if they're all here right now, and it doesn't matter that they're not. That's how we manage the concurrency with promises. When I make an AJAX request and an AJAX request, and all I care about is that both of them finish, I have promises that represent those responses, and I compose the promises together. And I let the promise take care of the details of it's not here yet. And on the other end, out spits my value from both of those having finished. So I don't have to worry about that coordination. I use promises to coordinate. So that's our first basic level understanding of concurrency. If you're not dealing with nested callbacks, you level up your game to understand how promises help you manage concurrency. They give a trustable, auditable mechanism for concurrency management. Great, so what about generators? Actually, generators really don't have that much to do with concurrency, but they are a really important side effect that we can use in our programming, because they solve this other major problem in our programming, which is that to express asynchronous programming is fundamentally non-reasonable. We can't reason linearly about our code when we have to jump all over the place. And whether you knew it or not, your brains are fundamentally, at the highest level of cognition, very synchronous and single-threaded. You process through your steps one at a time. You planned out your day very sequentially. Well, it sucks when our brains work that way, but that's not how the code that we're using works. And I have this theory, it's untested, but I'm pretty sure it's mostly true. Wherever there's a divergence between your brain and the JavaScript engine, that's exactly where bugs start to happen. Right? You want to look for bugs, find places where your brain doesn't work like the engine. So if we have this problem that our brains work differently, we need different programming patterns. And generators, very briefly, are a way to take what is fundamentally the necessity to orient different actions, one right after the other, basically to coordinate the responses to concurrent behavior. It's a way to do that in a very synchronous, sequential looking fashion. So we get synchronous, sequential looking code, even though it's fundamentally still asynchronous and performant. It's like the silver bullet, putting the best of the both worlds together. So we have these two things, promises and generators, and they are the building blocks of next generation asynchronous programming. If you don't fully understand how that pattern is going to improve your code, that's the place to start leveling up. It'd be nice if somebody would write a book about asynchronous programming patterns and help you figure all this stuff out. Somebody should do that. Promises and generators. So let me quickly illustrate in some code promises and generators. I've just got a simple scenario set up here. I got a fake AJAX call. Let me make that bigger so some of you can see it easier in the back. I got a fake AJAX utility, and it's hard-coded to pretend that I can ask for these three URLs, file 1, file 2, and file 3. So here's my setup. I'm going to ask for all three files in parallel. I'm going to ask for them in parallel, aka concurrently. So they're going to complete it in the same time frame, right? I'm not going to wait for the first one to finish until after the second one finishes. Or whatever. So I'm going to do so in parallel, but I want to coordinate the responses. So here's the coordination I want. I want to print the responses as soon as they come back. However, one additional constraint is I want to make sure that I don't print 2 before 1. So if 1 comes back right away, let's print it, and then we can wait for 2 and 3. But if 2 comes back first, don't print that yet, because 1 hasn't come back. This is actually a restatement of a pretty fundamental pattern in the UI world. We need to do multiple things in parallel, but coordinate their responses. But we do things ASAP because that looks more performant to the user. Okay? So how do we do that? Well, we could construct a really gnarly set of code around callbacks and things like that. But what do we do with promises? How do we express this with promises? So if I started out with this getFile function, I would need that getFile function to return me a promise. And then I would want to compose those promises together. So this is not taking a callback, it's returning a promise. That's fundamentally how we make an asynchronous action promise-aware. So this is how I do it. I return a promise from that getFile function. And you'll notice that it uses my fake AJAX under the covers, and it uses one of the two callback continuations to signal that the promise is completed whenever the AJAX finishes. So from the outside world, I simply call that function and I get back P1, P2, P3. I get 3 promises back. That's the easy part. The more complicated part is to think, how do I sequence the responses to those promises together to give me the properties of the system that I asked for? Well, it turns out it's actually not that complex. We chain promises together. I start out with P1, and when P1 completes, I want to output what it's got. Whether that takes a fraction of a second or whether it takes 10 years. I want to print it out as soon as P1 comes back. And then I want to wait on P2. Now there's only two possible scenarios. Either P2 has already finished, in which case we're just going to keep going on, or it hasn't finished yet and we'll just keep waiting. But you see, the value of composing these promises together in a chain is that I don't have to care about that detail because the promise is a time-independent wrapper. It manages that state internally. So I simply chain my promises together and I get the properties of that system that I'm asking for. So you say, well, that's all well and good. And I actually, a couple of years ago, so we started writing all of my code as promise chains. It's all well and good. We've got promise chains. That's way better than nested callbacks, right? Well, it turns out that's only half the solution. The other half is to make this more fundamentally sequential looking so that it works the way our brains work. And that's where generators come in. So here's the same program, but putting promises and generators together. And my solution is still to ask for the three files in parallel, but notice how I sequence the response. I call this yield keyword. Inside of a generator, which is a special function, I can literally locally pause the function to wait for an arbitrary amount of time for some promise to finish. Inside of the function, everything stops, like it's a blocking program. But outside of the program, everything else continues to keep going. That's the magic of generators. They have locally pausable stacks. So I just simply say yield where I want that pause point to occur, and I don't have to manage the complexity of how those compose. So now I rewrite all of my code using generators and promises together. So that's, if you don't know that stuff yet, that's where you got to start. You got to jump in to promises and generators. But actually, that's just review stuff. That's not even really what I wanted to spend some time talking about tonight. What I really want to talk about is some next level stuff. It's the stuff that the leaders of frameworks and languages are starting to talk about right now. These higher order patterns for concurrency. So I want to talk to you just a moment about a fundamental shortcoming of the promise. Promises are awesome. But there's one particular thing that we do a whole bunch in our programs that promises actually pretty much suck at. And that thing is responding to events. So let's look at this program. This program is I start out a promise, so I'm creating a promise wrapper, and inside it I set up an event handler on a button. And yeah, I'm using jQuery, I'm cheating because I just need shorter code for the slides. Doesn't matter what you use, but I'm setting up a click handler for some button. And fundamentally, when you click the button, the premise of this program is that it's supposed to resolve the promise and then print out the class name down here at the bottom, the next to last line, which is awesome for the first time you click the button. But fundamentally, there's a problem here because promises, one of their characteristics is they can only ever be resolved once. So this is going to work great for the first time you click the button, and every other time you click the button, nothing's going to happen because the promise has already been resolved. Uh-oh. We need some higher order pattern for managing concurrency when there's a stream of events. It's not just a single thing like a single AJAX request, but there's a whole stream of events. We have data streaming from the server. We have click events in our UIs. Whatever you think of that happens in your app, even single level events can be thought of as streams of events. They decompose to the same notion. So we need some higher order pattern. And one of the common patterns that's starting to get more popularity is called reactive programming. So we could reorder this program, by the way. We could invert the program and put the promise creation inside of the button. And you'll notice that basically I have to do not only the promise creation, but I have to also define the promise response inside of the promise creation. So this will work, but now we've inverted our code and created a violation of separation of concerns because the creation of the promise and the consumption of the promise have to happen in exactly the same code. That's an oops. That's a bad design pattern. That's a code smell. Promises are not up to the task by themselves. We need higher order patterns. So one of those higher order patterns is called concurrency. Is called observables, also known as reactive programming. So there's a huge library that it's got a lot of popularity. It's from Microsoft called RX, and it's been ported to like 15 or 20 different languages. It's awesome. It's also gigantic. It has hundreds of methods on it. The documentation's pretty stout. You probably should have a PhD before approaching it, because I still get confused reading some of this stuff. So is there a way to understand it in the simplest sense? Like, what's my hello world for understanding this thing? Well, an observable is fundamentally an attachment to an event stream that produces a promise for each event. It's taking care of that complexity, and it's harder than you think it is. It's taking care of that complexity for you such that I can define my responses to an event as a chain of promises and not worry about that whole like create the promise thing. So now I get the separation of concerns. I can declare my stream in one location, that is my producer of events, and I can declare my consumer in an entirely different place. And the consumer simply declares what is my response. So I make an observable, and they literally have a method in their API called fromEvent. So you have a standard DOM event attachment, and it'll produce a stream of events suitable for you to subscribe to in reactive programming sense. So here I have like map and filter. It's kind of like synchronous steps and stuff. But notice this distinct until changed. This is what makes observables different than just a fundamental synchronously chained API like a jQuery, is that actually the entire chain is kind of like a promise chain. So the entire chain can be asynchronous as necessary. Distinct until changed does not move on to the next step until there's been a change in value. That it does what it says on the box. It's distinct. It's waiting for a distinct value, and then once it's changed, it's waiting for the next distinct value. So if you have a stream of a whole bunch of x, it's only going to fire once until it gets a y, and then it's going to only fire once for the y, and then it's going to go back to x and only fire once. So it's a way to deduplicate a stream of repeated events. But fundamentally, a chain off of an observable is a way to subscribe asynchronously to a stream. So that's great. But that API is pretty complex. It's like 150K. Now, in all fairness, they're doing a rewrite to make it more modular where you can be able to choose, but now you're going to have like 250 API methods to figure out which ones you need to pick and choose from. It's a big task. I'm not saying it's bad, it's a big task. So I set about to try to create the small proof of concept for what reactive programming would be like, and I attached it to a library that I had already written for asynchronous flow control, and that library is called Asequence. It's the word async plus the word sequence mushed together because there were no other good names on NPM, basically. Okay? All the good ones have been taken. So Asequence, right? Now, I'm not even going to spend any time trying to sell you on Asequence. You like it, you don't like it, I don't care. But it is a library that brings together all these different programming patterns in one tiny library. It's like 7K. It has reactive programming. It has CSP, which we're going to talk about in a minute. It has promises and callbacks and thunks and generators. It's got it all in one spot. So you don't have to go learn a whole bunch of different libraries. It's the 80% case that helps you learn these principles. I designed it to help make this stuff easier to teach. So if you're looking for a place to learn, maybe that's a place to start. But how does Asequence do it? I call these reactive sequences. So I came up with a different word because I didn't want the Microsoft folks to get mad at me and claim trademark infringement or anything. I'm kidding. But I called it reactive sequences so you understand that it's a smaller subset of the same concept. How do reactive sequences work? Pretty much the same way. You subscribe to an event stream, and then you declare a chain of potentially asynchronous responses. And that chain can include promises and generators and other observables. In fact, one of the coolest things of thinking about observables, because they're streams, is we can actually do stream-oriented events. We can compose two smaller streams of events into one synthetic higher order stream. So here I've got a stream of key presses and clicks. Well, what if I wanted an event that represented when both of those happen at exactly the same time? I can simply call .all. So .all waits until there's an event from both queues, and then it fires a synthetic event to let you know both of them have happened. .any says I'm going to fire as soon as either one of them fires. So we have these ways to compose streams into higher order patterns and respond to the asynchronicity of our programs. So that's a real quick primer on observables. And if you're looking for the next place to go after promises and generators, you should learn observables. There's a pretty good chance something like this is going to land natively in the language sometime in the next year or two. All right, so the last thing I want to show you, and I'll end with some code, but real quickly I want to talk to you about a different pattern. This isn't getting any kind of press. It's actually a really old idea, invented back in the 60s. Really smart guy. He invented this idea called CSP. It stands for Communicating Sequential Processes. It's a different way of organizing how we respond to concurrency. And it models independent things as totally separate processes. And these processes operate independently, and the only way that they coordinate is when they need to synchronously message each other. So imagine thing A over here is spinning doing its thing, and thing B is over here, and at some point the two of them need to exchange a message So they both get to that point and they wait. So he gets to this point and she gets to this point, and now they can send a message, and then they go back to being independent. And we use a channel to do that. So it's like blocking on channels. That's how CSP works. Okay, so this is what it looks like. Looks like a generator, right? Because that's how we model CSP in JavaScript, is to understand generators, because generators kind of work like independent processes that can be paused and resumed. So I'm waiting on the put. Line 4, I'm saying yield put. I'm trying to put something onto a channel, and there has to be somebody on the other side ready to take it. And until somebody's ready to take it, I'm going to be blocked. Or if take happened first, I'd say I need to take something from the channel, and I have to wait until somebody was ready to put something on the channel. So both of them have to get to the point where they're ready to exchange, and then they unblock each other. Now this can actually be modeled not just across different parts of JavaScript, but you can actually model this remotely. I'm working on a research project right now, building a library that allows you to remote your CSP concepts across web workers or across browser windows or across the wire from browser to server. It's the same notion, just simply blocking and waiting for a message. CSP is where I think the next generation of JavaScript programming is headed. It's incredibly powerful. It's got a lot of places where it's even more powerful than observables. It's not necessarily the silver bullet, but we've got a lot of work to do to research this and make this go. And by the way, this isn't just some weird invention of mine. It was actually the model for concurrency in the Go programming language, as well as Clojure and ClojureScript. So there's some pretty smart people behind the CSP model. All right. This is just a quick example. It's a silly ping pong example. So I have 3 different instances of generators here. And each one of them is pretending, it's running independently, and it's pretending to play a ping pong game. Two different processes are ping-ponging back and forth with each other. They're transferring the ball by waiting and then sending the ball to the other person. So it says ping pong, ping pong. And then the table says time's up, game's over. Okay, so you can model higher level concepts in your user interface as independent processes that communicate with each other. All right, so my library, Async, also manages that stuff. And that's, you notice it looks basically exactly the same. I have the same API. So you can do CSP directly in that library as well. So what I want to finish with is a quick demo that is actually a repo. It's an ongoing project of mine. It's called A Tale of 3 Lists. So I'm going to pop this thing open. And it's a free repo, obviously, up on GitHub that you can go and look at. It's a demo of a whole bunch of event-oriented stuff that's happening. So it's a slightly more sophisticated hello world kind of thing with 2 different lists. And I'm going to show you how this works. I'm going to actually run the demo here for just a minute. Oops, I don't even have Wi-Fi. That's awesome. How do I get on Wi-Fi? All right. I should have remembered I needed to be on Wi-Fi. Hopefully this doesn't take too long. All right, so while that's connecting, let me just talk about it. There's a producer of items. It's like faking like items coming from a list. And then I have 2 different lists that are consuming that at different speeds. So there's sampled consumption of these event threads. And then I'm allowing you to click on different items in the list and move those items over into your own. And then, did I type it right? I missed an L. There we go. Awesome. They're going to have to cut that part out of the video, otherwise they're going to have to change their password.
Then there was no more bandwidth.
Then there was no more bandwidth. All right, let's see if this connects real quick so I can show you this demo and then we'll finish up. All right, here we go. So what's happening in the background is that it's going to start producing these items at a pretty rapid pace, and then I have 2 different lists that are consuming that at different speeds, which is why you see the items coming in. Now I can start to select items from this, and you'll notice they're animating, so asynchronicity is happening both in the back end as well as the front end. And I'm managing all of these events. Now this repo, I re-implemented this exact same demo, and you can pause the different lists. I re-implemented this exact same demo 7 different times using 7 different concurrency management patterns, from basic callbacks all the way up through promises and generators, all the way up through the reactive program that we just talked about, as well as CSP. So you have 7 side-by-side code bases to compare the relative strengths and weaknesses of these different patterns using a somewhat more sophisticated demo. So how many of you have heard of to-do MVC before? Okay? You know, to-do MVC is like how we compare all these different frameworks. I kind of think of this project as like the to-do MVC of asynchronous programming. And I'd invite other people with different libraries and patterns to try their hand at implementing it so we have side-by-side comparisons and we can learn better how this stuff works. So real quickly, as I finish up, I know they're about to throw me off, but real quickly, let me just show you some of that code. So here's the user interface for the reactive sequence. And I have a function here called toggle feed, which looks like a straight up regular event handler because it is. It's attached to an event stream. So my event stream might look like this. I'm saying el.on, so I'm saying I'm going to listen to some clicks and I'm going to turn this sequence of events that are coming in into a reactive sequence that I can respond to. So async library, we just say ar.of to give ourselves a reactive sequence, and then we push events into the queue, and we can consume events off the queue. It doesn't get it. This is about as simple as it can get, but now we have a reactive sequence that's attached to our DOM clicks. So I can listen for those DOM events and respond to them. So I can have higher order things like here's my feeds. So this is how I'm sampling the feeds at different rates. I set up an interval, and I'm pushing something into my reactive sequence at that slower rate. So I'm pulling stuff off of some other stream and throwing away stuff that I don't care about and pushing the last message on. So we can compose really complex UIs in terms of higher order streams, and the code's got way more details about that, so I'd encourage you to look at streams. Finally, the CSP stuff that I just talked about. There's toggle feed, but you notice now it's a generator, and you notice one important thing is it has a while true in it. What I love to say about generators is they're putting the while true back into programming. So we all know while true is like the evil of all programming, right? Because you kill your program. Well, when there's a pause point inside of your while true, it turns out that's exactly what you want. You want this thing to basically run forever for the entire length of your program. And it'll pause until somebody gives it some stuff to do, and then it'll resume. And then it'll pause again and resume and pause again and resume. So I have a while true loop here. And you'll notice that I simply yield on putting a message into a queue. So this is how I'm pushing out feed items, and I'm yielding to put. So I'm only going to run when somebody's on the other end ready to take the item off the channel. Now, I wish I had 2 full days to teach everyone here. I am going to be filming this workshop that I'm talking about today. I'm going to be filming that for front-end masters. I got a bunch of other training up there. So you'll eventually be able to get the longer form version of that. But I hope in just this few minutes what I've shown you is there's a whole lot more to asynchronous programming than the stupid little callback. There's a lot more sophistication. Now, you may be wondering why. Do I just get excited because it's a new, cool, shiny thing for me to play with? Here's why. This is why we do any of what we're doing in programming. This is why I do any of what I do to teach. Programming, the code that you write, you may think that the code that you write is all about the computer. It's all about instructing the computer what to do. I have 7 different programs that give it exactly the same set of instructions. The same ones and zeros. In fact, there's an infinite number of programs that can do that. The computer almost doesn't even care about your code. So if the code that you write is not primarily for the computer, who's it for? It's for other human beings. Code is fundamentally, first and foremost, a means of communication with other people. Your teammates, other people that consume your code, and your future self. So what we should be seeking to do is not fundamentally do stuff that we could never do before. I haven't shown you anything new that you could not have done before. Every single thing here you could have done before. What I've shown you is how to do it in a more reasonable, understandable, learnable, and teachable way. That's why ES6 is awesome, and that's why it matters. That's why asynchronous patterns matter, because they allow us to write code that is more expressive, more learnable, and more teachable. That should be our goal. When I refactor my code, that's what I'm worried about. How do I make my code make more sense? Not how do I make it do something more exotic. How do I make it make more sense? So I hope if nothing else, I've inspired you to go out and figure out how to make your code more readable, understandable, learnable, and teachable. There's a lot of great tools out there. Hopefully I've provided you some good materials to jump into that. So I'll finish with my final slide. To say thanks very much. I probably have run over my time for official questions here and discussion, but I'm going to be around the rest of the evening, so if you have any questions about this stuff, feel free to come up and check that out. Check out the books and ask us about Maker Square. We'd love to talk to you about making your code better. Thanks.